Today is February 22nd, 2006. We are at the Utah State University to perform some tests on a 6-inch and 24-inch check valves for flow and for differential pressure. In a few moments, as you can see, the test will start, and we'll start to perform this test with a small water flow inlet. Okay, we're going to start the flow of water. As you can see. Okay. As you can see, the water level is getting higher in the tank, and this is what will start the actual differential pressure once you encompass the complete check valve in water. Okay, as we can see, the check valve is partially submerged. It's actually about 60% submerged right now, so the plume of water is obviously slowing down. Okay, the check valve is fully submerged. Oh. Maybe even there's some wiring on that. There might be. Okay, we're going to start the testing now. All the fluke meters are in place, as you can see. I'll zoom in on them a little bit. There's the flukes that are going to measure the differential pressure. And we're going to be striving to seek for 10 points on this test on the 6-inch and on the 24-inch. We'll let you know in a bit. Here we go. We'll start testing now. Okay, it's going to be difficult to see this, but this is the check valve running at 6 feet per second. You can see the lips are about 25% open at this case. As we increase the flow, at one point the lips will be pretty much a full port design. And at that point we'll also be able to measure the head pressure that requires a full port. Each of these points to stop flow, not necessarily stop the flow, but minimize the flow so that he can take his 10 different readings at each sector point, and then we'll move up to the next amount of gallons per minute. You can see the flow is increasing the tank up to the flow out of the tank where it's actually flowing out quite heavily now. As you can see, I've zoomed in on the lips of the bill. We're still at the same test rating. You can see the lips of the bill are open, allowing flow out. Now we're testing at 10 feet per second, and the check valve has obviously opened slightly from the last test, but not a lot. You can see during periods of wave action, it is open quite a bit more. And you'll now gather data at that speed and we'll go from there. As you can see, the tank is obviously flowing a bit higher than what it was. This is a Marsh & McBurney potable water current meter. This is what's giving us the test. So right now we're at 10 feet per second, and eventually it'll gradually move up. This is the Excel spreadsheet that is plotting and determining each of the units. Flow measurement, as you can see, differential pressure, and exit velocity. So within these three parameters, we'll be able to supply any type of information that a customer may require in regards to the ProFlex series check valve. This is at 12.8 feet per second. You see the water has obviously considerably increased in flow. But this is what it's all about. Presently at 14.74 on the velocity side, so that's feet per second. And you can see obviously the check valve is allowing a lot more water flow through it. This is still done without a pump, so we're just measuring head. In a few minutes we will start a pump and increase a lot more flow into the check valve. very hard to see the bill right now, but I can see that it is open a lot more than what it was at the 10-foot mark, which is understandable. Okay, not sure if you can hear me, but we're up to 18 feet per second. We're going to be going for 3 more catch points yet. Well, you can see that the flow is definitely much, much greater. Pleasingly enough, the flow chart itself has got a beautiful graph to it. I'm going to show that to you in a minute. Once we get the next catch point, I'll show you the graph on the monitor screen. Pretty hard to see down there now. That valve has quite a large opening now. It's allowing it to flow at this 17 feet per second. Okay, right now we're at 22 feet per second. And we're now going to be changing over the flow meters. By the way, this water at this temperature, at this time of the year in Logan, Utah, right now is 37.2 degrees. So we are taking the water directly out of the river behind the building, and we're running it through the facility here. Let me show you a quick area of the facility. These are the flumes for the large diameter valves that they test. Coincidentally, we also have a check valve ready to be tested, which is right here. This one will be tested later today, and basically for the same type of test results. As you can see, it comes down through the pipe and then introduced into a large diameter pipe at the end with a large butterfly valve, which will allow the flow. Okay, so this test is over. We're just shutting down the pumps. We've finished our 10 steps, as you can see on the screen. I'll try and get us a bit closer here. I don't know what we can really focus in on. But that's it. So from there on, we do have the flow rates and a specific flow chart for a 6-inch ProFlex 710 check valve. Okay, we're getting ready to test the 24-inch check valve. It's all been set up. All the electronics are hooked up to it. The pumps have just started, so as you can hear, and we're ready to go. The water will be cracked on in a minute, and we'll start from there. There we go. Here's the start of the test. See, it's starting to flow water. Okay, as you can see, the water is up to about 3 feet per second. We're going to get ready to start testing in a minute. Okay, what we have here is 2,400 gallons per minute. Check valve's about a third full. Hasn't started to open the tapered section of the check valve yet, but it is allowing flow. As you can see, it's starting to bleed out some air as we're getting closer to the top of the pipe. Once it's full, this air will come out of the pipe and that surging will stop in the check valve. $710. Yeah. Just throw the dimension in, that's all, 24 inch. You did what?
These has to be built individually out behind the site. Is that true?
Now you can see the check valve is completely submerged. We're still burping out some air. We'll be ready to start testing in a minute.
6 inches of differential across that valve right now.
That's about 25% open. At this point it's hard to see, but the check valve is about 25% open. I don't believe the tapered section of the bill has started to open yet. Actually, if you can spot the yellow label, you can see that it's still on about a 30-degree taper angle. As you can see, the sluice is completely filled with water at this point. So we are running at exactly 6 feet of water depth. As we increase the flow, we'll create differential pressure between the valve and the inlet flow. The check valve is down there in the water. You can barely see it through the lens. We're going to start proceeding. We've already done test number 1 and test number 2, and the valve is testing satisfactorily. Here gives you quite a clear shot. Right now we're running at 13 gallons per minute. We're going to start the initial testing. This will be step 1 with the differential pressure. Here we're at the second step. We've moved up to 1,800 gallons per minute flowing out of this check valve, and the valve lips are about 15% open, but the tapered section is still not open, which is developing a great low head pressure type of check valve. Okay, we're now in the third stage. We're running at 6,000 gallons per minute right now. We're still in the 24-inch check valve. As you can see, the flue is quite full of water now, and pulling out the extremities of the flue. We're now going up to 9,000 gallons per minute, which will be our fourth step. At this point you can see that the flue has got so full of water at 8,000 gallons per minute that we've had to lift the gate slightly. You can see the pettibone has actually lifted the gate, which is going to allow a lot more volume of water through. Okay, we're now moving up to 10,000 gallons per minute, and the next one will be up around 14,000 gallons per minute. Okay, the flow is now increased. We're up to 13,000 gallons per minute. We're getting great results. Head pressure versus differential. It's really good to see. Okay, we're on the 6th step, which is 12,000 gallons per minute. Differential pressure right now. We're now at the 8th step, which is 16,500 gallons per minute. It's very hard to see, but if I stand up on top, you can actually see that the check valve bill is about 80% open at this point. And we've got 2 more steps to go. We'll get up to around 20,000 gallons per minute. I'm on top of the valve. Hoping I can show you that the bill is pretty much open. We're running at almost 17,000 gallons per minute right now. And we do have pretty much a full flow. Okay, as you can see, we've done step number 10. Differential pressure has been exceedingly well, was expected. We will be able to offer this style of check valve with a very low head loss, which is what the project was here today. And obviously we still will have our high pressure check valve for instances where head loss is not required. And the time is now 3:45, and the testing is now complete. This is Michael Johnson. He's the gentleman that's been in charge, and has been thank him completely for helping us out. Okay, the pumps have been shut off. We're now reducing flow through the 24-inch check valve. As you can see, the bills are returning to a standard vertical state. I'll just give you a few minutes of this. You can see that the head of water in the pipe is actually pushing the bottom of the check valve down, which in turn is opening the bottom of the lips.